Alright, Math 108. This is the lecture for Thursday, September 1st, 2011. And today we're going to be covering section 1.2, which is on graphs and lines. Really, the only graphs we're going to be looking at are graphs of lines. But before we start talking about lines and linear equations and whatnot, we have to introduce how we graph. And, again, a lot of this is going to be review, so I might be going through this a little bit fast. If you need to review it, talk to me. Go to tutoring, read through the book, call the online tutoring, whatever. There are a lot of resources available to you. So I started to type coordinate, and I'm going to write Cartesian plane. That is the basic way that we're going to be looking at graphs. What is the coordinate or Cartesian plane? Well, it is an infinite two-dimensional surface, goes off in left to right, up and down, and that is how we're basically going to represent graphs, points, whatever. And yeah, so let's take a look at what it looks like. This is basically the Cartesian plane. This is basically the coordinate plane. It consists of two number lines. We've got this horizontal number line, which we are going to call the x-axis, and any value along the x-axis we will call an x-value. We've got this vertical line here called the y-axis, and any value along the vertical axis will be called a y-value. Now they both meet at 0. The 0 of the y-axis and the 0 of the x-axis is where they meet, and that is our point of reference. It is our origin. It is how we orient ourselves in the plane. Let's notice that the x-axis has positive numbers to the right of the origin and negative numbers to the left. That makes sense. We read left to right. We think of left to right as going forward. And the numbers get bigger as we go to the right and smaller as we go to the left. Now with the y-axis, it makes sense that the numbers above the origin are positive, those below the origin are negative, and numbers get bigger as we go up and smaller as we go down. Great. So that is just the basic setup of the plane. Now, in the plane, we want to represent points, and the way we're going to do this is by ordered pairs. Now, an ordered pair is just a pair of numbers written in parentheses, x comma y, so x and y are numbers, and they're called an ordered pair because it matters the order that I write the numbers in. 1 comma 2 is not the same thing as 2 comma 1 because 1 comes before 2 in the first number and 2 comes before 1 in the second number. Now we care about ordered pairs because given an ordered pair we get a point. So let's see how we can plot the point 5, comma 10 in our coordinate plane. So let's plot my handwriting is only so good, but I'll do my best to make it look as pretty as possible. 5, comma 10. Well, note that I wrote x, comma y originally when I was talking about the ordered pairs. That means that the first value here, 5, we're going to be calling our x coordinate, and that means that it tells us where along the x-axis we are. So we go out to 5 along the x-axis, and that is where our point is going to be with respect to the x-axis. The second value, 10, will be our y-coordinate. So it's always x and then y. And it is 10, so we go up to 10 on the y-axis. Now what we do is we draw a vertical line coming from 5. That's a slightly different color, but it's still bluish. Okay. We draw a horizontal line coming from 10, and we see where they meet. They meet right there. They meet right there. So this is the point 5, comma 10. Great, fantastic. Now what if we were going to plot instead, just to show the fact that the order we write the numbers in matters. If we're going to do 10, 5, well, our x-coordinate 10 says let's go out to 10 along the x-axis, and our y-coordinate 5 tells us to go up to 5 on the y-axis. We go across from 5 to find out where we belong vertically, and we go up from 10 to figure out where we go horizontally, and that gives us this point right here, which is 10, 5. So the order I write them in matters. I get 2 different points. Let's do one more example. Let's say plotting -5, -5, just to make things a little bit simple. So our x-coordinate is -5. Well, since it's -5, we go to the left of 0 and we put our blue dot at -5. And since -5 is our y-coordinate, we go down below the origin to -5, and that is our y-coordinate. Now, since our x-coordinate is to the left of the origin, we'll draw a line coming from -5 on the y-axis going to the left. And since our y-coordinate is below the origin, we will start from -5 on the x-axis and go down to find our point. And we connect those dots, or connect those lines, and they hit each other right here, and that will be our point -5, -5. Alright, great. Now we would also like to be able to go backwards, and we'd like to start with a point in the plane and then get an ordered pair. So let's see how we can do that. For example, let's say we start with this point, I keep choosing the wrong color, this point right here. How do I find out what its coordinates should be? Well, I'll drop a line down to the x-axis to find out what its x-coordinate should be. And its x-coordinate is going to have to be -15 because that's where it hits. And to find where I am on the y-axis, I draw a horizontal line going over to the y-axis. Since we're to the left of the y-axis, we need to move right to the y-axis, and I hit at 5. That tells me my y-coordinate. Now those are my 2 numbers, and since x comes before y, I get -15, 5. And let's just do one more example of this. Let's actually do an example where I'm not actually on a number that I can see. So how about this point? To find my x-coordinate, I again have to go to the x-axis. The x-axis is above me, so I draw a line going up, and I hit at this point right here. Well, each of these little lines here represents 1, 1, 2, 3, 4, 5. So this value right here is 6. And we go to the left to find out where we are on the y-axis. That should be a straight line, sorry. Again, this is 2 below, -5, so that should give us -6, -7. So our point here then is going to be 6, -7. Great. So that is how we find the coordinates of points. Now, we have already described all of the points along the x-axis, or we've described these points here as the x-axis. I would like to note something. Any point along the x-axis, say this point right here, its x-coordinate is just 5, 6, 7, 8. It's 8, but what's its y-coordinate? It's not above or below the origin, it's at the origin. So if I go to the y-axis, I hit 0. So its coordinates are 8, 0. So I'm on the x-axis precisely when y is equal to 0. Similarly, down here, my coordinates are going to be 0, -5, because I'm not to the left or the right of the y-axis. If I go up to the x-axis, I'm at 0. So I'm on the y-axis precisely when x is equal to 0. Another thing I would like to talk about is the notion of quadrants. Now what are quadrants? Well, the x and the y-axis cut up the plane into four sort of rectangular shaped things, except for they keep going off to infinity. So here's one, here's another, here's another, here's another. And we give them names. This will be the first quadrant. This, just because of convention, mathematical convention, this is the second quadrant. This is the third quadrant. And this is the fourth quadrant. And the quadrants are really characterized by how the coordinates of the points there behave. Here, in the first quadrant, x and y are both bigger than 0 because the x-coordinate is to the right of the origin and the y-coordinate is above the origin. In the second quadrant, x is less than 0 because we're to the left of the origin, but y is positive, we're above the origin, so y is greater than 0. In the third quadrant, we're both to the left and below the origin, so x is less than 0 and y is less than 0. And the last possibility for the fourth quadrant is that x is to the right of the origin, but y is below the origin, so x is greater than 0 and y is less than 0. Alright, that's all I would like to say about the plane, and next we will talk about linear equations and drawing lines.